So what I was telling you is that when you determine, you want to know how far is 5EC from the face of the support. So this is the value for 5EC. Okay, this is 5EC, but we don't know where is it located. So how we can know where it's located from the face of the column? Very easily. So we have VU at support. We call it VUS. Okay, we have the value for VUS. So if you have VUS, okay, and you have V5VC, okay, you have these two values. The only thing you don't know how far is it from here up to this point, which we call it X1. So how we calculate X1, we could say W, which is the ultimate load that you have calculated from the dead and live load, after being factored, of course, each one with its own factor, times X1, and then you equate it to the difference of VUS negative minus 5EC, okay? Because I told you that this W times the distance would mean the difference between VUS, and if the distance is for like 5EC, then it's the difference between VUS and V5EC. If the distance represent 5EC over 2, the distance of 5EC over 2, so we can calculate if we label it as S2, so this would be X2, okay? So how we can calculate X2? The same way. W times X2, at that time would be W times X2, and then equated to the difference between VUS minus 5VC over 2. At this point would be 5VC over U. So this is how we calculate easily. If the, of course, if the shear force distribution is triangular, we can calculate it this way, okay? So that's how we calculate the location, because it's very much important to know where each one of these is located. We have to know where each one of these is located from the face of the support. This one at the support, this one at distance d from the support, this one, which is 5EC, is at x from the support, okay, and this one 5EC over 2. This would be the distance. Sorry, this would be the 5EC would be the zone beyond which, on the left, on the right side, beyond which there would be no shear reinforcement. No shear reinforcement is required when, from this zone up to 0. So no shear reinforcement would be required. Okay, so we have to know these things, these facts that we have to need. We need to establish the location of all the zones where we have shear reinforcement, or the zone where shear reinforcement ought to be calculated, and the zone when ACI code is recommending for shear reinforcement, the zone when no shear reinforcement is required. So once you establish the zone, all what you need is now to calculate the spacing, and based on the chosen phi. So if for phi 10, if you have decided on phi 10, for example, I give you three choices as an example. I give you three choices: phi 10, phi maybe 12, okay, or two choices would be enough. Okay, I give you two choices. So if I give you two choices, it would be like this: you start from phi 10. And then I might give, at the same time, I might give in the question like spacing restriction. So I might give like spacing should not be less than. It should not be, spacing shouldn't be less than, which is should not be less than. Okay, should not be less than. For example, I give you a value. It could be 100, 120 as an example. Okay. For your information, the spacing, the minimum that ACI code allow for spacing, okay, the minimum spacing that ACI code allow is about 100 millimeter. Okay, this is the minimum spacing ACI code allows. Okay, ACI code allow for 100 millimeter of spacing. Okay, just to know. So if I specify, I told you, I say spacing shouldn't be less than 150, okay? It should not be less than 150. And then I have given two choices, as I told you, phi 10, okay, and phi 12. And you started with phi 10. You started with this phi. And then you've got a spacing, calculated spacing from phi 10. You've got like 140 as an example, okay? And that was the least one, okay? You've calculated this required spacing, and out of the four choices that you have, you've got that this would be the least one. But I have given this warning that spacing should not be less. So what you do, you jump into the second phi. Why? Because your spacing is less than 150. So the larger the phi, the larger the spacing would be, because the stronger the stirrups is, the larger the spacing would be. So you calculate now S naught based on phi 12. Based on phi 12. So this one was based on phi 10. Okay. So this would be based on phi 12. You calculate it, and you see that spacing probably is improved to 1 for 140, for example. Sorry, for 145 as an example. Okay. So improved, a little bit of improvement, not much. In that case, what you do, you decide on phi 12. If I didn't give phi 13, then you wouldn't go for phi 13. If I've given phi 13, then you go for phi 13. But if I've not given phi 13, then you've got 145 millimeter as spacing. So what you do is that you cannot choose this. You choose this spacing based on phi 12. Okay, you choose the spacing based on phi 12. That would be the minimum allowed spacing if I specify it in the question. If the spacing, minimum spacing, is being specified that shouldn't be less than a certain value, then you cannot choose. But if I have given only phi 10, then you just rely on phi 10, okay? But if I've given choices, then you jump into the second choice. And in case if you have jumped into the second choice and you've got the S based on the phi 12, and you've got it like 160 millimeter, so that would be your minimum S value. That would be the minimum that you can use for spacing. Okay. Okay. So anyway, that is not the case in this question. So we have specified zones. Do you have any question? Trabale?
مامۆستا لە دۆزینەوەی سپێسینگەکە ئەیڤیەکان نووسرا دوو جارانی هەفتانۆ مامۆستا ئەو فای چەندی لۆ بەکار هاتێ ئەگە فای دەبی دەبرێ دوو جارانی هەفتاویەک نەک هەفتانۆ
ئەگەر فای هەفتانۆ بوو لەوانەیە 11 فای 11 بەکارهێنەوە
مامۆستا ئەگەر فای 12 بی دەبی دوو جارانی 113 بەس یعنی ئێستاوە نازانین نەک دەیە
ئەگەر 12 بێ 11 والله
لا مامۆستا تەواو دەردەستن بە دە بەکار هات
ده
فایەک دێ هەفتا و هەشت پۆینت پێنج
7.5 ڕاستەکەی وایە ئەوە لە حاڵەت ئەگەر if phi 10 was used and the area is not taken from the table, you have calculated. So once you calculated based on your calculation would be phi, the diameter square over 4 times pi. Okay, in this case you're gonna get 78.5 millimeter. But if you take it from tables, the actual area is 71. Why is 71? Because the phi itself is not 10, is 9 point something. Okay, 9 point something that is less than 10. So that's why you won't get 78. But if the phi is given and you don't know, and it's not, and the question has not given you the area of that phi, so you have to calculate it. So once you calculate it, you're going to get 78.5. You round it up, though I don't recommend any round up in this figure, but it's been rounded up here. Okay, rounded up to 79. So it's roughly equal to 79 millimeter. Okay, that's how.
مامۆستا ینی ئێستا چونکە لە ئیمتحان ئەو تەیبڵ نادێت کەواتە ئەمە بە دوو جاران 79 دەکەینەوە نییە چکە تەیبڵ نییە بە خۆمان حسابی
You
دەکەین
have to calculate it. If it is not given, I told you just now, if it is not given, you calculate it. If it is given, it's given from a table. Okay, it's given from the table, and usually the table's value is less than 78.5. It's 71. It's 71.
Wow.
Okay.
71 بەڵێ
Because the actual
Sorry.
diameter of the bar is not 10. It's labeled as 10, but it's not 10. Okay.
بەڵێ دەزان
Okay.
مامۆستا لەو تازە کە گوتت ئەگەر ینی بکەمە مەرز برێ سپیسینگەکەم برێ لە هەندە ڕقەمەکمان دێ برێ لە هەندە نابی کەمتر بێ ئەو کات دەبی فای 12 و فای 13 تاقی بکەینەوە چێ هەیە لە ینی ئەو مەرزێت
It depends on the choices given to you. If I have given you a single choice that you should provide 510 only for the reinforcement. So once you calculate the spacing on the reinforcement given, if it is less than the limited one that I have specified in the question, like shouldn't be less than 100. For example, if I said like spacing should not be less than 100 millimeter. Okay, and then based on 510, I have dictated 510. I dictated 510 is the only choice you have. Okay, this is the only choice you have. So if I dictated this, so you calculate S based on 510, and for example, you get it 90. Okay, you get it 90 millimeter. So what you do, you choose this spacing because I dictated that this is the minimum. But if you have like two choices, 12, 512, then you jump to 512. If it is more than 100, then you choose 512. If it is less and I have given 513, you jump to 513, then you check again. If it is less, then you go to, if it is more, then you decide on the 513, okay?
بەڵێ مامۆستا ئەدی ئەگەر فای 13کەش بچووکتر بوو ئەو کات دێینە
Then I also explained it to you before. If it is less, then you go and decide on the dictated limit that is given in the question. Should it be less than 100? Then I choose 100. Then I choose 100 because 513 is giving me 95. So I choose the 100 one. That would be the okay.
Oh, that's
Okay. So what else? Okay, so now we have specified the zone, we have specified the distance from the face of the column to where the moment is located, the shear force is located, and we know how to calculate those locations. Now we come down to what? Now we need to calculate the spacing, no, not the spacing, the number of the stirrups, okay? Number of stirrups. How we calculate number of stirrups. I give you, there's another thing that I didn't told you about, I didn't mention to you, is that the first stirrup, okay, we always design on the critical, but it doesn't mean what we design on the critical, okay, location. It doesn't mean that there would be no shear reinforcement before the critical. We always place a single, okay, we always place a single stirrup, okay, at a distance. Assume that this is the stirrup, okay, this is the shear reinforcement, okay, this is 510, okay. We place it from the face of the column at a distance equal to S over 2. Which S? The one you have calculated, and afterwards you have compared with S max, and you decided on the least one. So that would be S is the least one you've got, okay? The least S, the least S you've got, okay, over 2. This would be the first place for your reinforcement, okay, the first stirrups. So now, how do we calculate how many stirrups do we need? Okay, I have located this. So I need to know how much of distance do I have within which steel reinforcement is needed. If it is from this location up to 5 VC, which is this one. This is the 5 VC, okay? Okay, if I have this distance, which is, I called it X1, okay? If I have X1, so the distance within which I need to provide steel reinforcement would be X1 minus S least over 2. S least over 2. S least over 2. That would be what? That would be the zone, I call it zone 1. Or I call it Z1, okay? I call it Z1. That would be the zone or the distance, you could say, okay, where I need shear reinforcement. Okay, now how can I calculate? How can I calculate how many shear reinforcement do I need? So all what you do, you have this distance, which is Z1. I call it Z1 because X1 minus S over 2 is equal a new distance. We are given this new distance, which is Z1. From here to here, from here to here, it would be Z1. Okay, this would be Z1. So how can I know how many stirrups I need? The number of stirrups would be equal to what? Would be equal to the spacing, which is the least one. I always decide on the spacing over the distance, Z1. That would be the number of spacing. For example, I get 4 point something, 4.3, 4.5, 4.9, 4 point whatever value, okay? So what I do, I say, okay, now I have n is equal 4.3, I consider to be 5. So the actual distance that will be reinforced will be the actual distance, how to call it, actual distance that will be reinforced, actual distance will be reinforced, will be equal to the number of stirrups, which is 5, times the spacing, which is this one, S least, times the spacing, which is S least. Okay, we don't need to call it S least because S naught is the one, okay? S naught is the one we have decided on. You don't need to call it S least and S most. There's no S most, in fact. It's all S least. So all what you do is you call it S naught. This is the one that you have decided on. This is S naught 5. Okay, S naught is that one. So you have S naught. This is S. Okay, hold on, let me change it. So all what you need, just specify your S naught. Okay, S naught. The actual distance, this is, sorry, I've got this, oh, this is 5, in fact, this is 5. Okay, it's confusing. This is 5, okay, this is S naught. So number of stirrups times S naught. That would mean the actual distance that will be provided with steel reinforcement. You don't count this. This is already placed, okay, this is already placed. So you count. Now, n times S naught, usually if you get 4 point something and you round it up to 5, the distance will go beyond this zone. The distance will be beyond this zone, will go beyond. So it will be like the number of stirrups. So each spacing, you place a stirrup. Each spacing, so you have 1, 2, 3, 4, 5, and 5 could be here, okay? So that would be the last stirrups would be at this location. So this would be the actual location that is beyond the zone that we have established, okay? Beyond the zone that we have established. If you understand this one, that would mean we've understood how to place those steel reinforcement. Okay. Zenit.
مامۆستا ئەو سپەیسینگە لە نێوان فەیسی یعنی سەرەتای دەستپێکردنی دایاگرامەکەیە لەگەر
Yeah. All your focus should be on this diagram, okay? So the diagram, you go away from this, which the diagram, it means the face of the support. It could be column, it could be wall, it could be anything. So from the face, you go far away up to S not over 2 to place the first reinforcement. Okay, now this is to count for the face reinforcement. Now I need to know how far I need to reinforce with the requirement amount of reinforcement. So what I do, I know that this is the zone. This would be the zone where shear reinforcement is required. So what I do is I calculated this x1, okay? So x1 minus S naught over 2 would give me the zone where I need shear reinforcement within. So once I got x1, the number of stirrups would be equal to its spacing over x1. So you get a value like 4 point something, 3 point something, all right? So we round it up. Yeah, okay. Okay. So that's all. So now once you have, for example, you finished. Now you have 5 spacing, and you know the last spacing would be not here, exceeded, came to here. So you place it here. This would be the last. So the following zone, this is Z1. How can we know from where to where? Okay, if you know that the location of your last stirrups from here to here, we know it. How do we know? Yeah, because this distance, I know. This distance is equal to Z1 plus S1, S naught over 2. Why I know it this way? Because the first stirrups you have placed was at a distance equal to S naught over 2. So you know this distance. Yes, I know. And you know the distance from here to here. Yes, I know. Is Z1. So S over 2 plus Z1 would be the location for the new stirrups, for the minimum stirrup that ACI code recommends. So this would be the new location, okay? So from here, I need to, up to 5VC over 2 that I have already calculated. Also, I know where is it located. I have labeled it as X2, okay? If I know X2, and I know that S over 2 plus Z1, I have this distance. So I know the zone, I know the distance in which minimum amount of shear reinforcement. So how I do know about the number? So the number is, again, is about spacing over distance. Do you have the spacing for that? Yes, I do. I chose the least. It's not the one that you have calculated for the required one. It's the one that you have decided based on 4 choices. Okay, 4 choices. You choose the least. So either D2, which likely D2 is the governing one. So either D2, either 600 millimeter, either 3 AVFY over B web, or 16 AVFY over root square F sub C prime B web. You choose the least. That would be your spacing over the distance. This would be X2, this would be the actual zone that we have calculated. So it would be you could say S naught over 2, you add it to Z1, and then this distance subtracted from X2, or X2, because X2 is larger, so X2 minus S naught over 2 plus Z1. So you have specified the distance within which the minimum the minimum shear reinforcement is recommended by ACI code. So you get a value like maybe 2.1, okay, or maybe 1.9, okay. So that you round it up. If 1.9, you round up to 2. If 2.1, then we see if we round it up to 3, does it go beyond the 0 line? We have to make sure. If it doesn't go, then you place it. If it goes beyond, so we don't round it up to 3. We just make it 2, okay? So we make sure that the syrups stays within this. It doesn't overlap the other side. Because what you have designed for this side of syrups, you multiply it by 2, you get the other side reinforcement. So what you have, the number of syrups you have designed for this side, based on similarity, the other side should have the same number of serum reinforcement. So you just multiply it by 2. That's why the steel that if you round it up to 3, and after you calculated 3 times the spacing, and it goes beyond the zone, it goes beyond the zone within this, it goes beyond the 0 shear reinforcement, then you have to get it back to 2, and based on that, you calculate the number of shear reinforcement. Okay? That's how we calculate the shear reinforcement, number of shear reinforcement. So what you have calculated for this side, you multiply it by 2, so you get the number of shear reinforcement for the whole beam, from the left to the right, so for both sides. Okay? Any question? That's how we calculate. That's all what you need to know about placement. It's all about these, okay? It's all about these. So now it's, if we solve it the same way. The only thing we don't, for example, the spacing, if we get S like 133.5, you divide it by 2, you place the exact. Over here, for practicality, they just round it up or down, up to closest. For example, if you get like out of the spacing, if like the spacing is 133 over 2, okay, or 133.5 over 2, so you won't get like a nice figure, like to be practically to be placed for the syrups, okay? So it's like you will get something more than, for example, is 65. Hold on, let me check what was the spacing. The spacing we've got is 130. Okay, 130. If you divide 130 over 2, you'll get 65. Okay, but he has given 60 millimeter for practicality. For us, if we divide it by 2, you place it at 65. Okay, so that we all of you will get the same result. I don't want different results. Okay, just for practicality, he has reduced it to 60. Okay, we don't reduce it to 60. The 130 spacing is divided by 2, so that is where the first location of the first syrups is 65. It should be at 65 from the face of the support. So you place it 65, don't change it to 60. But in this example, it's changed. Why? For practicality purposes, he has changed it into 60. Okay, for just practicality. So it would be an easier figure to memorize, maybe to implement in the field, because it's easier for someone to tell him it's about 6 centimeter than saying it's 6.5 centimeter, right? That's why it's not used. 65 is not used because 65 millimeter is like 6.5 centimeter, which is difficult for, to implement it in the field, in reality, for the labor to know 6.5 is difficult to implement. Okay. Any question? Do you have any question? Balay Radwan.
زمان استاذ او سرتا 133 درسو راوندی کردو بو 130 دو 130 كاي دابش کرد
ده كان هيجي ما هيجي راوندي ناكين وتم بيت او راوندا for practicality to cast 65 ئەگەر ڕاوندی نەکا بۆ پراکتیکاڵەتی ئەبێتە 6 سانتیم و نیو ئەو نیوە زەحمەتە لە حەقیقەت 6 سانتیمەکە ئاسانە وانە
وای
لەبەر ئەوە 17 هین ئەگەر مەسەلەن 68 وایە ئەیکردە هەفتا لەوانەیە ئۆکەی 65 کردێتی 6 بەگەر من بێڵم ئێوە وا بکەن هەر یەکێ وەڵامێکی مختلفی ئەبێ وانە
ڕاست
لەبەر ئەوە چیت بۆ دەرئەچێ ڕاوندی مەکە بە نسبەی سپیسینگ بە نسبەی نمبر ئۆف ستیل بارس نا ڕاوندی بکە و حسێبیکە زام ئەکسیدی زۆنەکەکە یان نا ئەگە ئەکسیدی کرد بە نەختی قەینە ئەگە ئەکسیدی زۆنی ئاخری کرد ئەوەی باسم کرد پێش نەختێ ڕاوندی مەکە بگەڕێ لەسەر بوو ئەوەی وتم دوو ستێراپس پوینت شتێکێ پوینت 1 با بڵین ئەگەر دەرچوو سێ ستێراپس ئەکسیدی ئەمە ئەکایە ئەم زۆنە دەرئەچێ ئەچێتە سەر ئەو دیو ئێمە نامانەوە بۆ ئەو دیو دیزاینکەین بەس ئەم دیو بەس ئەم دیو ئەگەر لە ناو زۆنە مایەوە ئۆکێ بێڵە ئەگەر لە ناو زۆنەکە تێپەڕین نامانەوە بۆ ئەو دیو دیزاینکەین چونکە چیمان هەیە لەم دیو بۆ ئەو دیو هەمان شت دائنێ ئەگە پرسیار هەیە بیکەن ئەگەر نییە that would be the end of today's lecture و امتحانیش داخل نییە شیر rinforcement بەس چیمان خوێندووە لە ئەم سەمستەرە داخڵە بەس شیر rinforcement داخل نییە بەڵێ دڵژین
مامۆستا لە بۆ دۆزنەوەی فایەکەی جارێک سپیسی سێزدە 133.5 ماڵ دانا کە کردی 8 پای و جارە تیش 250 ئەوە کەماندانا سپیسینگی کام ئەو کردی 5 ماڵستانی 5ەکە هێڵ دەبژێری
باش واللهی ئەبێت تێبگەم باش کام زۆن کام شیر rinforcement
ئەگەر بخەی سلایت دواتر
هی دواتر
بەڵێ
هی دواتر ئەمە بەکار ناهێنی ئەم پرۆبلەمە
نەنە مامۆستا بەستم لە ئەوەی دۆزنەوەی فایەکەی بوو کە کردی 5
دۆزینەوەی فای چییە
مامۆستا ژمارە ستیل بارەکە
number of steel bars n
بەڵێ
فای چییە من چوزام فای چی
مامۆستا لەم تێکەر
ئەخە من چۆن تێگەم ئەگەر لێ تێک بچێن تێناگەم number of steel bars
سپیسی 250 میلیمەکەی بەکارینایە و 5 دەرچوو ژمارەی ستیلەکان ئەو هەڵدەبژێرین
کوانی لەکوێ نازام چوزام ئەو هەڵەبژێریانە 5 دەرچووە چوار ئەوە تا 4.64 راوند ئەپی کردووە بۆتە 5 5 تایمز 250 چەکی بکە دوای چەکی بکە ئەکسیدی زۆنەکە کایانە یعنی ئەکسیدی ئەم هێنەکە ئەم زۆنە دەرئەچێ لەم دێرە ئەگە دەرناچێ داینە ئەگە دەرئەچێ ئەبێ بگەڕێیتەوە ئەبێ بگەڕێیتەوە هین کەم دانێ ینی 5 دانەنەی 4 آخر شت هینی زۆنی ئەخێر نابێت تێپەڕێ بچێتە ئەوبە چونکە سمەت هێنا ئەمە لایەکە دیزایانی بۆ ئۆکەی ئەو لاش دیزایانی خۆی نییە چونکە سیمەتریکەڵە هەمان دیزاینەکە هەمان دیزاینە ئۆکەی حتا سیمەتریکەڵیش نەبێ ئۆکەی کێکە یاریوان بەڵێ
یازەوە بۆشی سەڵسیەکەی هەر بەکارنێ ناکرێتی بە 250
مەگە نەمانوت ئەوە بەکاری نەهێناوە چونکە ئەوە دیزاین نییە ئەوە منیمەم ئەیسی ئایکۆد داوای کردووە لێ ئەو زۆنەی کە بۆی کردووە ئەمەی کە ئێستا باسمان کرد ئەمە چونکە ئەیسی ئایکۆد خۆی داوای شیر rinforcemenتی کردووە لەو زۆنەی کە 5VC کە هین VU لە 5VC کەمترە لە 5VC کەمترە لەبەر ئەو فۆرمولایە بەس بۆ دیزاین بەکارێت ئەوە ئەمە توانی ئەم فۆرمولایە ئامە بەس لە کاتی دیزاین بەکارێت ئەگە پرسیار هەیە دقەیەکمان ماوە پاشەوە ڕیابات و تۆ
مامۆستا
آه.
سپیسینگی یەکەمان لە زۆنی یەکەم بەکارهێنا لۆ دۆزینەوەی ئێنەکە چونکە دیزایانی دەکەین وە نییە ستیرابسەکەی دیزاین دەکەین
إيه
ئەدە سپیسینگی 130مان بەکارهێنا ئەوی گوتت لە کاتی دیزاین ئەو سپیسینگەی بەکاردێن
لكاتي ديزاين أو فورمولا بكارعيني نك أو سبيسي أو فورمولا بكارعيني بيش قال لك فورمولا تاني دي
بەس مامۆستا ینی ئەو فۆرمولەیەن بەکارهێنا لە دۆزینەوەی نەمبەر ینی ژمارەی ستیرابسەکان لە زۆنی یەکەم ینی